Okay, once again, remember this is just a flyby, just an overview of, it's an overview of the chapter. You're going to pick up a lot from practice questions and looking through it, but we're getting some highlights, and then we'll come back. Now, I told you I had some good news earlier and some bad news. I said the good news is we're not on lymphatic system anymore, but the other good news is you won't have a test this week, okay? We won't have a test this week. Instead, we're going to do the overview of chapter 17, chapter 18 this week. You'll go through, you'll listen to it, you'll go ahead and do your practice questions, but then the test will come next week when we'll do videos just simply on 17 and 18, and we'll do the videos over the test material. So, hey, that's the good news is we don't have to spend a lot of extra time studying for a test this week. Well, let's talk about the pancreas. And it's important for us to look at this diagram on 668. On 668, we have a diagram showing the gallbladder, showing the pancreas, and it's showing the stomach. So when we look at this diagram, okay, the pancreas, of course, is located right in the middle here, okay, and then we see this bile duct, okay, and then we see the hepatic duct that actually goes out to the liver, okay, so that actually goes to the liver. So the liver then is putting this bile in the gallbladder, who is fuel injecting this to the bottom of the stomach. You remember I was showing you at the end of that last picture, the duodenum is at the bottom of the stomach. But let's look, we've got something else, okay? We've got this pancreas, weird looking thing, almost looks like kind of like a grub worm there. But this pancreas is located right in line with the stomach. You know how the stomach has this rounded shape? Well, what fills that rounded shape? The pancreas. What does the pancreas do? The pancreas produces, okay, pancreatic juices, okay? So where does our stomach acid come from? Well, it comes from the pancreas. So see where it says pancreatic juice over here on page 669. Pancreatic juice contains enzymes, okay? So an enzyme is something that breaks something else down. It digests carbohydrates, fats, proteins, and nucleic acids. The carbohydrate digesting enzyme called pancreatic amylase, okay, anytime you see the word ACE, it means ASE, okay, it means that it eats and dissolves, okay. So amylase splits molecules of starch and glycogen into disaccharides, okay. All right, now that's what I want to talk about, okay. So saccharides, okay, there's certain amino acids in our body, okay, and everything is made up of these amino acids. So when we eat a hamburger, okay, we're going to get carbohydrates, we're going to get starches, we're going to get fats, we're going to get proteins, but we're getting a lot of amino acids in there. And so that's what we're doing in the stomach. The stomach is trying to bust everything up, okay? It's a big thing because we got the bile that's trying to break this down, but we also have the pancreatic juices, and it's breaking things down from polysaccharides, poly meaning long chains of molecules of things, okay, into disaccharides meaning two, okay. Later on we make monosaccharides. And so what's the stomach doing? What's digesting? Larger to small. Okay, what happened in the mouth? We talked about the saliva, the enzyme that breaks that down, okay, so that broke down sugars and starches. Then we get to the stomach and we take care of carbohydrates, lipids, proteins, break them down in smaller material, and continues them doing what? Going down the alimentary canal. And once again, it's 8 meters long. You say, well, we're not 8 meters long, right? No, because our intestines are going to do this. And then we're going to wrap our large intestines around. We'll talk about that in a little bit. But so there's the pancreas. What does the pancreas do? It produces pancreatic fluids that help break things down. Where's the pancreas located? It's located directly into the stomach. Okay, now I want you to go to, let's see, I am on, okay, here we go. Page 676, 676. Okay, so now we're we're out of the stomach. Okay, now you see this picture of the stomach, and then you see the duodenum. Now remember, the duodenum is where that bile goes in, but we say at the opening of the stomach, but not the opening of the esophagus, but the opening at the bottom end of the duodenum. Okay, so then look how it goes. This alimentary canal keeps on going, but now it goes through the stomach, the duodenum, and now it's going to be all turned around Now look at this intestines. Why is it turned and why is it curved so much? And what does the inside of the intestines look like? Remember we showed you that earlier, okay? Flaps of skin in there, or not skin, but digestive tissue, all right? So that we get as much surface area as we can. And it says the 3 parts of the small intestines, okay? Now, I want you to look at this. The 3 parts of the small intestine. Now, the duodenum extends into a large part. Now, one of the things we're going to do in this class, we're going to dissect a pig at the end of the class. And you're going to have to take the alimentary canal and identify all the different parts. And you're going to have to identify the 3 parts of the intestine. And the first one is the duodenum. Now it's larger. Here's the stomach, okay? And then it breaks, the stomach goes into smaller into the duodenum. Now, as you get into the duodenum, okay, it's still a pretty large area, okay? All right, you see that? The 3 parts of the small intestine are the duodenum, okay? The J-E-J-U-N-U-M, okay? Jejunum, okay? All right? And then the ileum, I-L-E-U-M. All right, now, so I want you to see now, let's go down here, and so when we talk about, let's look at the pronunciation, J-E-J-U-N-U-M. So it's a J, little e, ja, and then jo-num. All right? Okay, and the ileum, all right, so it says, there is no distinct separation between the jejunum, all right, and I butcher it myself, and the ileum, but the diameter of the jejunum is usually greater, and its wall is thicker, more vascular, and more active than that of the ileum, okay? So what are they saying here? What are they saying? Well, what they're saying is that the duodenum, that it goes from larger to smaller, okay? So it goes from larger, okay, to smaller. What are we doing? We're compacting food, we're passing down, we're absorbing more stuff out. Now, isn't it interesting? Let me go to, let's go over to, first of all, 17.9, small intestines. The small intestine is a tubular organ that extends from the pyloric sphincter, which is the connecting for the stomach, to the beginning of the large intestines. With its many loops and coils, the small intestine fills much of the abdominal cavity. Okay, so most of your abdomen, your abdomen is the small intestines. Now let's go over, okay, all right, now you know the 3 parts of the small intestines that we talked about there. Now let's talk about absorption in the small intestines, all right. So page 680, okay. So now I want to recognize, I almost did it a while ago, but the villi, once again we're on page 380, the villi, V-I-L-L-I, greatly increase the surface area. That's what we drew earlier. It's the villi that can get filled and get stuck with all the gluten, okay? So the villi greatly increase the surface area of the intestinal mucosa. Mucosa is the lining of the intestine, making the small intestine the most important absorbing organ in the alimentary canal. The small intestine is also effective in absorbing digestive products, okay? Water, electrolytes, okay? The water and the electrolytes are absorbed through the small intestines. Now, what happens when it's absorbed into the small intestines? That's incredible, because then we have these capillaries that are along those intestines. So in the villi, the actual villi itself, have these little capillaries. So as the intestines absorb the water, guess what happens? That goes directly into the bloodstream. Isn't that amazing? Okay, so that's why my friend who was so dehydrated, even though he was drinking all this water, the villi were filled with gluten. So the little capillaries, so he couldn't even get water in there to be absorbed by the capillaries to go into the bloodstream. So that's a problem. So the other thing that we have in the small intestines is we're absorbing not only water, but we're absorbing electrolytes, the salts that we need. And we need those, we need salts, we need electrolytes to be able to have a synapses. So when our brain connects, remember an axon connects a nerve. So whenever we connected that nerve, the electrolytes allow us to be able to turn on the synapses, the neurotransmitter, the chemical switch, allows us to turn it on or turn it off. Okay. So once again, absorption in the small intestines is the key. Now, even in the mouth, okay, even in the mouth, we have what's called mucosa, which is the lining inside the mouth, And there we have what's called subliminal, okay? And so in that case, we're actually to absorb the sugars that come through our mouth, that absorb the sugars. They go directly into bloodstream and capillaries in our mouth. So that's why sugar can make us really hyper. We can get that into the bloodstream right away. When we go down into the small intestines, then we absorb them directly in the bloodstream, but it's taking it a while to get there. Now, we're almost there. Let's go to the large intestines on page 683. All right? So now we see this big picture of the large intestines here. Okay? Now, the large intestines are so named because its diameter is greater than that of the small intestines. This part of the alimentary canal is about 1.5 meters long. So about 1.5 of the 8 meters is the large intestines. And it begins in the lower right-hand side of the abdomen cavity where the ileum joins to the cecum. From there, the large intestine ascends to the right side, crosses obliquely to the left, and ascends into the pelvis. At its distal end, it opens to the outside of the body. So it's kind of interesting. So whereas the small intestines are all lined up and contains into our abdomen, the large intestines run all the way over the top. Isn't that interesting? So you see the shape of the large intestines on the outside and the small intestines on the inside. So the small intestines are all wrapped up, and we didn't have a size on there a while ago, and I don't even want to tell you wrong, but there's a lot more length to the small intestines. The large intestines are 1.5 meters, and you'll learn as you're studying the other what the length of the short intestine, of the small intestines are. That would be the long intestines. But the small intestines are a lot more longer than 1.5 meters. So where is the large intestine located? It's located around the outside of the small intestines. Now, let's look at the parts of the large intestines. The large intestines consist of the cecum, the colon, the rectum, and the anal canal. All right? So, when we look at that, okay, we see the cecum. All right? We'll talk about these a little bit as we go. We have the ascending colon, okay? When somebody has a colonoscopy, we go in through the anus and then go all the way up in there and look into the different parts of the colon. The descending colon, the transversing colon, the ascending colon. When we say colon, we're talking about all of the large intestines. So that kind of gets us a quick overview of the large intestines, small intestines, and we're going to stop right there. And that's just, once again, that's an overview. Remember, next week I will give you the exact test material for chapter 17. The next video, I'll give you an overview of chapter 18. See you then.